I'm going to explain about CMOS inverter. Inverter function, you know that when you are giving 0, it gives the binary 1 output. When you are giving binary 1, it gives the 0 output. Just it gives the inverting output, that is the inverting function. So I will explain. This is only the symbol for inverter. But if you want to design a circuit, so internally it requires the transistor. So I will explain how it is working. So it requires a NMOS transistor and PMOS transistor. Both the transistors they are using. So one is complement to another. That's why it is CMOS inverter. So this is PMOS transistor, and this one is transistor T2 is that is NMOS transistor. So how it will work, I'll explain. So here you can see this. This is the PMOS transistor, PMOS, and this is NMOS transistor. NMOS transistor, source gate drain and source gate drain. Here, when you are giving binary input 1, assuming binary input is 1, so then you can say this. This is NMOS means NPN transistor, NPN transistor. So in this case, when you are giving binary 1, so it is VGS is sufficient to goes to the on condition. Transistor T2, I am assuming this is transistor T1. So VGS is sufficient. Input voltage between gate and source is greater than VT, threshold voltage for the transistor. Then it will goes to, just assume input voltage is 2 volts, is greater than threshold voltage of the transistor is 0.6. So condition is satisfied. So then the transistor T2 goes to on condition. So but here this is an 1 to negative. It is NMOS means this is not, this is PMOS means PNP transistor, PNP. So here it is 1 to negative. So it is not, VGS is not sufficient here, because 1 to negative means it is reverse bias. So P to positive to negative, it is reverse bias. So VGS is not sufficient. Just assume it is 0.5, just assumption is 0.6. Threshold voltage for the transistor 0.6. So in this case, this will goes to off condition transistor. T1 is off condition. So hence the VDD is will not flow from here to here because it is off condition. So across the output nothing else, nothing is there, hence the output is 0 while giving binary input 1. So what will happen when you are giving Vin is 1, transistor T1 is off, transistor T2 is on, but output across the output nothing is there, so therefore 0 output. Coming to the binary input 0. Binary input 0. While giving 0, what will happen? We will see. So I am giving A equals 0. So 0 to, that is positive means it is reverse bias assumption. 0 means negative, negative to positive. It is reverse bias, negative to positive. 0 means negative, P means positive, it is reverse bias. So means it will not sufficient. VGS is not sufficient here because it is reverse bias case. So that's why it is, just assume it is, I am assuming here 0.2 only. So condition is not satisfied, hence the T2 goes to, transistor T2 goes to off condition. And here 0 to negative, so there is a sufficient because it is negative terminal only. So means here it is enough to goes to the on condition. VGS is greater than VT because negative to negative forward bias. So therefore VGS is sufficient. So hence it will goes to the on condition. So now the VDD is flowing through this direction because T1 is on condition and T2 is off. So means it will not flow through towards T2. So hence the output is 1, binary 1. You can say this, when you are giving 0, binary output is binary 1 is the output. So while giving 0, T1 is on, T2 is off, and output is 1. Output is 1. So like this we can explain the CMOS inverter. Why CMOS means both the transistor we are using NMOS and PMOS transistor. That's why it is CMOS inverter, complementary metal oxide semiconductor inverter. So and the input outputs are same. So when the input is high 1, output is V out is 0, nothing else. When the input is 0, output is high. So these are the characteristics curves. So this is V out versus V in. These are the characteristics. If you take one more curve. So this is about inverter. While giving 0, you will get 1. While giving 1, you will get 0. So but it requires 2 transistor NMOS and PMOS transistors. So this is the characteristics curve. So thank you. If you have any doubts, you can send me.